first things first in this question, get rid of the double angle formula and the triple angle formula. So sine 2 theta is fine because that is equal to 2. So this is one to learn. Now I don't know about you, but I don't know cos 3 theta off the top of my head. So I'm going to need to use the addition formula for that. Cos A plus B is equal to cos A cos B minus sine A sine B. That's one to learn. Therefore, if we replace this one by theta and this one by 2 theta, I'm going to get that cos 3 theta is cos theta cos 2 theta minus sine theta sine 2 theta. Alright, I'm going to expand this one. Sorry, this one. What's the best to do for cos 2 theta? Now I need to think about this. Let me come back to that in a second, because there's 3 different versions of expanding cos 2 theta. So back to the equation, I've got root 2 sine theta cos theta plus cos theta plus cos theta cos 2 theta minus, now I'm going to replace this one, so it's going to become 2 sine squared theta cos theta when I replace sine 2 theta by this thing here. And all of that is equal to 2 sine theta cos theta plus cos theta. Alright. I think to be safe, just for the moment, I'm going to replace cos 2 theta in its most standard form as cos squared theta minus sine squared theta, and then we'll see what's happening. Before I do that, sometimes when I'm solving these questions, I say, like, don't divide by things because they might be 0, but in this case, I think it's just going to make life easier if we divide through by cos theta. So we divide every term through by cos theta. So it's going to go from here, here, and become 1, here, 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 and here, and become 1. So we have to include the fact that cos theta might be 0, or then we're left with what we've just simplified it to. And then I'm going to replace this, like I said, cos squared theta minus sine squared theta. Okay, I've just had a second little thought about this, and actually we've already got a sine squared theta in there, so it does make sense to replace this cos squared theta by 1 minus sine squared theta, so we don't have any cos squared thetas in there at all. You don't want sine squared and cos squared in there. You can help it, and also now I've just got everything in terms of sine. So yeah, I didn't quite spot that right at the start, but that's fine. You know, sometimes you've got to roll with it, and then it will come later on. So I could have simply replaced cos 2 theta by 1 minus 2 sine squared theta. I didn't, but I have done now. So let me just put this together. I might, shall I expand this out? I probably should. So 2 root 2 sine theta plus root 2. Oh, I've just spotted something else actually. This is good. So we can basically cancel this plus 1 with this plus 1 here. So it's going to become minus 4 sine squared theta, because I've got my minus 2 sine squared theta and I've got another minus 2 sine squared theta, and that is going to equal to sine theta. It's worth, okay, it's between 0 and 360. It's going to be worth, so we don't forget about it. Let's just get the solutions to cos theta is equal to 0. And we're working in degrees here, so it's going to be 90 and 270. Okay, back to the more complicated one. Not really liking this, if I'm honest. But let's go with it. We've got to. So I'm going to get everything onto the right-hand side. 4 sine squared theta plus 2 minus 2 root 2 sine theta. I've minused this, and then I've brought it all together under the sine theta. Minus root 2 is equal to 0. Okay, now I would expect this to factorize, so we just got to give that a go. There's no way this is going to work if I put a 2 and a 2 there, surely. No, actually, I think it is. Sorry. 2 sine theta. So I tend to, for these sorts of things, I tend to just sort of use the kind of trial and error method, just see what works. So that will give us 4 sine squared theta, and then we need a minus root 2, and we times these two together. So let's go with we need a minus root 2, because now we'll get minus 2 root 2 sine theta, so that's brilliant. And then this will be plus 1. So that will work, because we'll get 4 sine squared theta, we'll get minus root 2 sine theta, which is what we've got here. We'll get plus 2 sine theta, which is what we've got here, and we'll get minus root 2 from that as well. So you've just got to, you don't see that straight away, you've got to practice it. Don't think you want to be going down the route of the quadratic formula in this question, honestly. Just like, you know, expect it to factorize. This is a non-calculator question, so it will factorize. So that means sine theta is equal to minus a half, or root 2 over 2, which is 1 over root 2. And now we just need to deal with this. So I'll deal with the minus a half first of all. Sometimes it can be, so it's going to be down here and down here. Okay, well I know sine theta equals a half implies theta is equal to 30, or it would be 150. So that means sine theta equals minus a half. That implies that minus sine theta is equal to a half, which is actually the same as sine of minus theta. This is an odd function, so sine of minus theta is equal to a half. So theta is equal to minus 30 or minus 150. But what we can do is, because it's periodic in 360, we can just add 360 to that. So it's going to be 330, or if you add 360 to this, it's going to be 360 minus 150, which is 210. Now I just massively overcomplicated that, didn't I? Because I could see that actually, look, it's anti-symmetrical. So if this is, I don't know why I did that, but I got there. If this is 150, then we would add 30 to get to 180, add 30 again, that will give us 210, that would be minus a half. And then the other one is, because this is 30 here, because it's like anti-symmetric about this line, then I just need to start at 360 and minus 30. So maybe you got there that way quicker than what I just did. But anyway, those are going to be our answers. and then 1 over root 2. I think I'll just draw another diagram. Okay, this is a classic one to know. It's 45, and then the other one's going to be 118 minus 45. It's going to be 135. So overall, theta is going to be, what did we have? I've already forgotten. 90 and 270. So it's going to be 45 degrees, 90 degrees, 135 degrees, 210, 270, or 330 degrees. Those are all the values of theta for which this equation is true.